Next, we're going to look at the parallel line relationship, and this is proved using similar triangles. It actually comes out of the side splitter theorem. The proof involves basically breaking up this region here into two separate triangles and setting up a side splitter setup. You should be able to see this in your book, and we talked about it already in class. The big idea with the parallel line relationship is if you have parallel lines being cut by transversals, the transversals will be cut in the same ratio. So for example, if the upper sides were maybe half as close together as the lower two lines, you would see that same relationship over on the other side. Okay? In this particular example, you can see here the ratio between the upper part of the transversal line and the lower part should be the same ratio on both sides. Okay, so for example, 4 over 6 is going to be equal to 6 over x. Okay, and you can cross multiply there. You get 4x is equal to 36, and x is going to end up equaling 9. Okay, I'm going to go ahead and write that in. You can see all kinds of other relationships. The upper part over the whole will be equal to the upper part over the whole. So you could do something like 4 over 10, whole side like there would be 10, would be equal to the upper part over here over the whole part of 15. Okay, I think you can check that. That's 2/5. That also is going to simplify down to 2/5 or 0.2 if you wanted to, sorry, 0.4 if you wanted to write it that way. You could do the lower part over the whole and the lower part over the whole. So you could do 6 over 10 is equal to 9 over 15. Okay, those were both simplified down to 3/5. Left to right, the ratios are the same. So for example, if you wanted to do something like 4 over 6 is equal to 6 over 9. That would work, okay? Likewise, if you want to do right over left, 6 over 4 equals right over left, 9 over 15, that'll work, okay? You could do the upper right over the upper left, and then you could do the whole right over the whole left, okay? As long as you're consistently matching up the same parts, either top to bottom or side to side, you're going to be able to set up proportions that work, okay? This can be extended. You could draw an additional parallel line in. Let me extend this down just a little bit here. And I could draw another line in that's parallel to those lines. And you know, let's say that this is 8 and this side is x. Again, all of the parts of this will be broken up in the same ratio as all of the parts on the other side. So I could do like 6 over 8 is equal to 9 over x. I can make a proportion like that. So 9 over x equals 6 over 8. You can do that kind of thing. I could do the upper part over the bottom part is equal to the upper part over the bottom part. You can combine segments together. I could do the upper 2/3, 10, over the lower part. So upper 2/3, lower part is equal to the upper 2/3 over the lower part over on the other side. Okay, and if you solve this proportion in this particular case, I think x would end up equaling 12. If you cross multiply here, 72 divided by 6, you'd end up getting 12 for your value of x. And of course, you get x for 12, being 12 there as well. So obviously, you can't make a proportion that's got more than 4 things in it, but you can still compare any 2 parts from the left to any corresponding 2 parts from the right, or any parts from upper part, lower part, upper part, lower part. Any of those proportions that you create will also work.